Okay, something that you are going to see on Study Island that you may think is new is actually not, but I want to do a quick video just to show you what we're talking about when we talk about average rate of change. So average rate of change is the slope between any 2 points. So when we are looking for average rate of change, we've already learned how to find it. It's just finding the slope between any 2 points, and it doesn't have to be used on a linear function. We can use it for any type of function. So what we're looking at is here, let's see an example of, here's a curve. Okay, notice it's a curved line, so it's not linear. And the graph shows the distance in miles, height from a camp in H hours. So here's our hours, here's our miles. Which hourly interval had the greatest rate of change? And so what happens is average rate of change allows us to find a slope between sections of a graph, whereas when we talked about with linear graphs, the rate of change is always the same no matter what 2 points we choose. So we can use any 2 points to find our rate of change, and we use the slope formula for that. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, the change in y over the change in x. That's the formula that we use for that, for slope for linear. We use the same formula down here, we just have to be specific about what intervals we're working with because of our because it's not a linear function. So what it's asking us is we have to find the rate of change for each of these different sections from our 0 to 1. So from this point to this point, and we can rise 2, run 1. So this has an interval or rate of change of 2. Whereas this section going from this point to this point rises 1.5 and runs 1. So it has a slope of 1.5. Then we go from hour 2 to hour 3, so this point to this point, it rises 1 and runs 1. So it only has a slope of 1. Then we go from hour 3 to hour 4, and it rises half and runs 1. And so we end up with 0.5 as our slope. So what happens here is each section, each hour, has a different rate of change, and it's asking us for the greatest rate of change. So what we're doing is we're finding from this point to this point. It's not a straight line, although it looks pretty straight. It's actually a curve. And so we can't find the exact rate of change, so we find an average. And so we use the average between these 2 points. And then we find the average of these 2 points. And then we have the average of these 2 points and these 2 points, and then we compare them. So what happens is the hourly interval that has the greatest rate of change is this first one, 0 to 1, that has a highest rate of change of 2. Okay, so let's look at another example. So over here we have an astronaut. He drops a rock off the edge of the cliff on the moon. The distance is in meters. The rock travels after t seconds, can be modeled by this function.
Hannah Rogers, come to the office.
Sorry about that. So the can be modeled by this function, and ask what is the average speed in meters per second of the rock between 5 and 10 seconds. So it's going to have a different speed all the way along this because it's not a linear function. It's actually a quadratic. And so we need to know just what is the difference between from 5 and 10. So here's what happens. We have to create a table. So in this table, we input our x values, 5 and 10, because that's our time, and we are looking for a y value. So we take that 5 and we plug it in up here, 0.8 times 5 squared, and we get out the number 20. I do the same thing with the 10. 10 squared times 0.8 gives me 80. And so what I do here is I find my average rate of change between these 2 points. So I can use the slope formula, which is 80 minus 80 minus 20, and 10 minus 5. So these 2 y values subtracted and these 2 x values subtracted. That gives me 60 over 5, which reduces to 12, which is the answer that I found here. So when I look for average rate of change, you'll always be given either 2 x values or the ordered pairs, or you'll have a graph or something to look at, and you'll be able to see that it is the slope of those lines. And so you may have to do a little bit of calculation to find what the y value is or something along those lines, but you'll have 2 points that you'll be looking for the average rate of change in between. Alright, so a couple more examples. Let's look at this A. So ask to find the average rate of change of this formula on the intervals below. Okay, so when we talk about intervals, remember we're actually going to be talking about a domain here. So from 2 to 5. So x value, y value. X value is 2 and x value is 5. We need to find the y values that correspond with that. So we're going to plug them in. 3 times 2 squared plus 5. 2 squared is 4 times 3 is 12 plus 5, so 17 is the y value that corresponds with that. This is not an ordered pair. Pay close attention. These are brackets. It's an interval. So these are only x values. We have to still find the y values. And then 5. So 3 times 5 squared plus 5. So 25, which is 75, plus 5, which is 80. So we have an 80 here. So to find the average rate of change here, we're going to have to take these two y values and subtract them. So 80 minus 17, and these two x values, 5 minus 2. So what happens, I have 80 minus 17, which is 63, and I divide that by 3 minus 2, which is 3. And so my average rate of change ends up being 21. Okay, that's my average rate of change for those two across this interval. And that would be an example of saying, like on this first page that we talked about, it would be from the interval 0 to 1, or from 1 to 2. We just happen to do interval 2 to 5 here. Okay, so here we have, again, negative 3 and 2, same equation. So, and again, negative 3 and 2 for my x and y. I'm going to plug in negative 3. So negative 3 times negative 3 is 9. 27 plus 5 is 32. And then on 2, we do 2 squared. It's 4 times 3. We've actually already done this one. It's 12 plus 5, which is 17. Okay, so now we do the same calculation. 17 minus 32 over 2 minus negative 3, which is 2 plus 3. So 17 minus 32 is negative 15, positive 5. Our average rate of change here is going to be a negative 3. Okay, so there's always the calculation portion of this. So slope, if we have something that's given to us in a graph like this, yeah, we could count and we can do rise over run, but we don't always have that option. Sometimes you have to do the calculations, and that's where you may have to create your table. You may have to do something along those lines, and you're probably going to have to use the slope formula on these. Okay, so let's look here. So now we are given this equation, different equation. This is what it looks like on the graph, and we're asked to find the average rate of change between these two numbers. So from here to here. So this is the point negative 1, negative 5, and this is the point 1, 3. So we're looking for from the interval from negative 1 to 1. Luckily, we've already been given the y values, so we didn't have to do the calculations, but we could have plugged those in, and we could have gotten the matching y values, the corresponding y values. But we're doing from interval negative 1 to 1, so it's these 2 points. So we're going to plug those values into the slope formula. So we have 3 minus a negative 5, which is plus 5, and 1 minus a negative 1, which is positive 1. So we end up with 8 over 2, which is 4. So we have a slope of 4 for these two, which would make sense. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, and run 2. So it's a rise of 8 and a run of 2, which is a slope of 4. Okay, so again, we can count them, but most often you're going to be given an equation and an interval. You have to find the y values that go with that interval. Just keep in mind that when it gives you an interval, they are your x values. Unless they tell you otherwise, these are going to be your x values. You still have to find the y values by plugging them into your equation. And then finally, using your slope formula to find that. So I know average rate of change sounds a little bit complicated. It is not near as complicated as it seems. You're just looking for the rate of change using the slope formula with the given interval that they give you. Okay, so very specific domain. So if you need help with it when you come across these on your study island, please come and ask me. I will help you work some of these out so that you can figure this out. If you get stuck on something, just let me know. I'll be happy to help, but just wanted you to have a quick set of notes on these so that when they come across, you won't be blindsided.